Shri Gurubhyo Namaha. Welcome to our online learning initiative Ekalaiva.
Today, we are going to discuss equations of motion by calculus method. All of you are familiar with that. What is velocity and acceleration? Velocity is defined as rate of change of displacement and acceleration is defined as rate of change of velocity. So, first let us derive first equation of motion. First equation of motion. Let us consider u be the initial velocity and v be the final velocity and a be the acceleration. And here we are going to assume uniformly accelerated body. Okay, so the acceleration is defined as a is equal to dv by dt. Now let us assume when time is equal to 0, velocity, that is initial velocity, will be taken as u, and when time is equal to t, velocity is equal to v. So we are going to integrate this equation on both the sides. So when you integrate it, before that, let us rewrite this first equation as dv is equal to a dt. So now we'll integrate this. Integral dv is equal to integral a dt. So here the limits are u and v. So the lower limit will be u and upper limit is v. When here the limits are 0 and t. So when time t is equal to 0, velocity is u. When time is equal to t, velocity is v. So when we integrate this dv, we will get v between the limits u and v. And we cannot integrate a. A is a constant one. So 0 to t dt. So what will you get when you integrate this? You will get u v a. When you integrate this dt, you will get t between the limits 0 and t. So now we are going to substitute the limits value here, upper limit minus lower limit. So v minus u is equal to a t minus 0. So you will get at. So v minus u is equal to at, or v is equal to u plus at. So this is the first equation of motion. Now let us derive second equation of motion. So the second equation of motion, I told you that velocity is defined as rate of change of displacement. So v is equal to dx, or we can also take ds divided by dt. Again, let us consider ds is equal to v into dt. And already we know from the first equation of motion, what is this v? V is equal to u plus at. So, u plus at into dt. Okay, again, we are going to take when time is equal to 0, distance traveled is equal to 0. When time is equal to t, then distance traveled is equal to s. Okay. So now we will integrate this equation. So let us take, this is our equation number 2. So when you integrate on both the sides between the limits 0 and s. Here again integral 0 to t. We are integrating with respect to dt. So u plus at dt. So integral 0 to s ds is equal to 0 to t u dt plus integral 0 to t at dt. So when you integrate ds, you will get s. Between the limits 0 and s is equal to, you cannot integrate u. When you integrate dt, you will get t. Between the limits again 0 to t plus again this a cannot be integrated, only we are going to integrate t. When you integrate t, you will get, so keep a as it is. When you integrate t, you will get t square divided by 2 between the limit 0 and t. So substitute the limits value here, children. This is s minus 0. Again u into t minus 0 plus a. Instead of this t, you have to substitute t. So t square by 2 minus 0. So s is equal to ut plus half at square. So this is your second equation of motion. S is equal to ut plus half at square. Now let us derive third equation of motion. So we are going to do third equation of motion. Third equation of motion. Already we know that acceleration and velocity. What is acceleration? A is equal to dv by dt. Here we are going to multiply and divide this by ds. So dv by ds into ds by dt. Okay. So now dv by ds into, we know that ds by dt is nothing but v, that is velocity v. So you just cross multiply here, ads is equal to v dv. Okay. So again we are going to take when time is equal to 0, velocity is equal to u and distance traveled is equal to 0. When time is equal to t, velocity is equal to v, distance traveled is equal to yes. Okay, so now again we are going to integrate this equation. Let us consider this equation is our third equation. Okay, so when you integrate on both the sides between the limits, integral 0 to s, a ds is equal to integral u to v dv. So we are going to integrate this. When you integrate, so integral a ds. Okay, so a cannot be integrated a. When you integrate ds, you will get s between the limits 0 to s is equal to, we are going to integrate integral v dv. So when you integrate v dv, you will get v square by 2 between the limits u and v. So upper limit minus lower limit again here. So s minus 0 is equal to, here upper limit is v. So v square by 2 minus u square by 2. So you can write as is equal to 2 is common. So v square minus u square divided by 2, or cross multiply this, you will get 2as is equal to v square minus u square. So the third equation of motion becomes v square minus u square is equal to 2as. So we discussed first equation of motion as v is equal to u plus at. Second equation is s is equal to ut plus half at square. And third equation is v square minus u square is equal to 2as. Now let us do fourth equation of motion also. So we are going to do fourth equation of motion. So again we know that v is equal to ds by dt. So ds is equal to v dt. And already we know that what is this v from the first equation of motion? U plus a p into dt. Okay. Now here we are going to take when time is equal to n minus 1 second, then distance traveled. Distance traveled is equal to Sn minus 1. When time is equal to n second, then distance traveled. Distance traveled is equal to Sn. Okay. So again we are going to integrate this equation. That is ds is equal to u plus at into dt. So we are going to integrate this equation, integral, the limits are s n minus 1 s n. So you have ds here is equal to integral n minus 1, that is distance, n minus 1 and n, u plus at into dt. So when you integrate this ds, you will get again s n minus 1 s n. So when you integrate this, so here you can write this as, take this u. So you are going to integrate only this dt alone. N minus 1 and n are the limits, plus a integral n minus 1 and n t dt. So you can write it as s upper limit is sn minus s n minus 1 is equal to u. When you integrate this dt, you will get t. So t n minus 1 and n plus a t square by 2 n minus 1 n. These are the limits. So now we are going to substitute the limits here. U. So upper limit is n minus lower limit is n minus 1. Plus take this 2 also outside the bracket. So a by 2. So again n square minus n minus 1 the whole square. Okay. So you can write it as this n minus n will get cancelled. You will get only plus 1 alone here, right? So n minus n, when these two will get cancelled, minus of minus plus 1. So 1 into u is u. So you can write it as u here, children. So then what else you have? A by 2. Now this is n square minus, this is a minus b the whole square, n square plus 1 square minus 2n. Okay, so you can write it as sn minus sn minus 1 is equal to u plus a by 2. This again, this n square get cancelled. Again, what do you have here? Here minus, here plus 1. So minus 1 plus 2n. So you will get 2n minus 1. Okay. So here you can write this as, where this sn minus 1 as, which will be taken as snth. Okay, so snth is nothing but sn minus sn minus 1. So this can be written as, this formula is for distance travelled in nth second. Distance travelled in nth second. So u plus a by 2 into 2n minus 1 is the distance travelled in nth second. Okay. So these are the equations of motion. We can derive all the equations of motion by using calculus method, that is integration method. To receive our online lessons, please press the subscribe button and you will receive the latest updates. Thank you, students.